Okay, so we're looking at rotations today. There's nothing in there, buddy. I'm sorry. Sorry. Thursday? Okay. You can either remind me tomorrow, or I'll get with you Friday, come to my flex. Okay. We've covered translations and reflections. We took a quiz on it. You will get your quiz back tomorrow to see how well you did. Some people did great. Some people not so great, which is why we did the notebook check today, so that when the not so great quiz goes in the grade book as the first grade for this new 9 weeks, you'll also have that nice little notebook quiz grade in there, so it's not going to be as bad. Remember, we have 9 weeks. It's actually 10. We have 10 weeks till we're out of school. It's 3 till spring break, and then it's 7 after spring break. Okay? So, while this is when most people want to start getting too relaxed and lazy, this is when you actually got to crank it up. Otherwise, your relaxed and lazy is going to show in your grade. Okay? And I don't want that. I don't want anyone in May all of a sudden scrambling. I'd rather you work really hard right now, and then in May when you're like, ooh, 2 weeks left, that's when it's, you know what I mean? I don't say you can relax then, but you don't have to worry about scrambling. All right, translations. A couple of vocab word reminders. Remember that the image before you do anything to it is the pre-image. Once you do something to it, it's the image. The written rule is the fancy wording for the formula, right? If it was a translation, that means you are simply sliding it one of 4 possible ways, right or left, up or down, right? And it never changes orientation if it's a translation. It stays, like I think of an L. It would just be picking it up and sliding it. Then we did reflections. We covered reflecting over the x-axis, which means you end up changing the sign of y. So there's 2 ways to get it. You can write the coordinates, change the sign of y to get the new coordinates and graph it, or you could just come to the picture and count, right? Can you see? Can you see? All right, just make sure. If I can't see your eyes, I know you can't see this. You would count. So, like, how far is D from the x-axis? And then you would count past it and plot it. If you're reflecting over the y-axis, then the x-coordinate has a sign change. So you find the y-axis, you take a point, and you just count how far away it is, and then count past it. Right? We already did that. Then you reflect over a random horizontal line. It's the same concept as reflecting over an axis in that you're counting. The difference is you have to know where that horizontal line is. You have to graph it. So if I say reflect over the line y equals 1, this is where Hoy Vux comes in. If you don't understand Hoy Vux, once again, here is an explanation. Y equals 1. What word has a y in it? Hoy. So that tells you to draw a pointing to it, y'all. This is where second is just like draw a horizontal line on the y-axis, crossing at 1 in this case. So you find the y-axis, you find 1, and you draw a horizontal line. Then you just count to reflect the shape. Okay? If it's a vertical line, this one's reflecting over the line x equals -2. So what word has x in it? Vux. V stands for what? Vertical. Drop a vertical line crossing the x-axis at -2, and then you just count your shape. Okay? then there was one more reflection, which was y equals x. And this was the one I warned you about. I said this is the only one that you can't count. It's very awkward to try to count it, although Jay definitely counted his, which is fine. But it's easier if you just know how to apply the formula. And I said if you'll draw these arrows, it'll remind you that y becomes x and x becomes y. So you're just switching them, which means you need to know the coordinate points of the pre-image. Then you switch them, and then you graph the new image. Okay? And the last reflection in your book we said was a nice to know, but not a must know. Now we're looking at rotations. Okay? I will pass you a highlighter. Well, there's only, never mind. Who needs a highlighter? We're going to highlight some spots. Catch. Jay, there's yours. Catch. I'm trying to throw them up high so you have a chance to. Oh, sorry. Catch. Sorry. Catch. There you go. Nick, hey, you get that one. Catch. At least you didn't get orange this time. Or do you want orange? No? All right. With your highlighter, first of all, let's take note of that we are rotating clockwise around the origin. Now, what does the word origin mean? The center of the coordinate plane. And where, can you tell me the actual coordinates of that?
0,
0, 0. So when I say rotate around the origin, I am referring to the coordinate point 0, 0. Meaning, like right here, if you put like an X, that stays put. Now, the state used to make us teach rotating around the origin and rotating around the random point. They have since taken out the random point. We are now just rotating around the origin, which is nice. We're going to leave the random point in the booklet, but we will skip over it. Before we start rotating, we got to do a little damage control. This is just because y'all's generation, not through no fault of your own, has not grown up on analog clocks. You may not even know what an analog clock is. Huh? Yeah, you do, because they are teaching it in 2nd grade. So I know y'all learned it in 2nd grade, but I also know if you don't use it, you lose it. You ever heard that phrase? Mm-hmm. It's the same thing with knowledge, muscles. If you don't use it, you lose it. Okay. So I have an analog clock, and that's a clock that is shorthand, longhand, right? Or shorthand, bighand. And it rotates, and you have to read time. You need to think of high noon as when the shorthand and the big hand are both pointing up to the 12. That's high noon. It's also midnight, but we're not going to talk about midnight. We're just going to say high noon. Notice that the numbers start counting to the, all right, thank you. Y'all help me out. Second was, so at high noon, the numbers start counting to the right. So if you ever forget what direction clockwise is, an analog clock, which is this one right here, would show you that it's high noon and then it's in the direction that it starts counting, okay? Which means counterclockwise would be high noon to the left. So you need to know clockwise is rotating to the right. So I'm going to say high noon, and we'll put a 12 there, and then it's rotating to the right. That's my little way of showing, like, we're thinking of a clock at noon, and it's going to the right. Now, it's not y'all's fault. Y'all's generation is digital. If you've got clocks at home that are connected to the internet or some type of signal, network signal, you don't have to change your clocks, right? If you have a clock, like mine's not changed, I got to get up there and change it. If you have a clock that is not connected to the network or internet, it will not change on its own. You have to manually change it, which is why they tell you change your clocks this weekend, which we just did. Okay, so we're rotating clockwise. We have a pre-image right there, triangle ABC. Instead of showing you one page per 90 degrees, 180, 270, I just put them all on the same page because you're going to see how to do this, and it's the same concept. I need you to understand we are going to cover 3 types of rotations: 90, 180, or 270. Now you might notice there's a little negative sign in front of them. And it even says right here, negative rotations. You don't have to worry about that. That's there for someone who plans to go to pre-cal, your senior year. Okay, I went ahead and planted that seed because that comes up in pre-cal, and it's good to know, but you don't have to know that. You're not going to be tested on that, okay? I will always tell you what direction you're turning, whether I say clockwise or CW. In fact, it would be nice if you just come right here and write CW in parentheses. That would be my abbreviation for clockwise. Now, there is one rotation that I will not tell you the direction, and that's because it doesn't matter. Do you know which rotation it would be? Great point. That's fine. I'm going to go to her first, then I'm going to come to you. Why does it not matter which direction you rotate 180 degrees? Think about it. If I'm standing, if you're a skateboarder, skier, trick shot, or anything like that, I'm trying to think of like dirt bike rider or something. But if you're facing in one direction and you do a 180, it just means you turned around, right? Right? Now, does it matter which way I turn to get there? No, it means I ended up facing the opposite direction. That's a 180. So if I ever give you an example of a 180, don't say which way, because then I'm going to go 180. Does it matter? And then you should be like, oh yeah, no, it doesn't. Okay. Now, why is 360 not on here? 360 puts you right back where you started, so that's kind of boring, right? So I'm not going to ask you a 360 question because, one, I'd be scared to see if anyone got it wrong, in all honesty, but two, it's boring. You know what I mean? The majority of people would get it right, and it would just be the same answer it started with. Let's talk about the 90, 180, 270 real quick. You see this coordinate plane? How many quadrants are on a coordinate plane? 4. Oh, 4. Can you tell me how many degrees are in each quadrant? Imagine if I was like up here rotating to here.
90.
What?
90.
90. Think about it. The x-axis is perpendicular with the y-axis, right? So what does that mean is in between them?
90.
A 90. Well, what is right here? What about here?
90.
What about here?
90.
Okay, so if I say we are rotating 90, visualize it as say I'm in quadrant 1. Say I'm rotating, I'm just going to do a circle, and I'm going 90 clockwise. Well, that would mean I'm rotating to the right 1 quadrant, and I'd land here. Does that make sense? What if I said I was from here, quadrant 1, rotating 90 or 180, 180? So does direction matter? No. So this would be 90, and this would be 180. So notice it's directly behind it. What if I said I was rotating 270? So that's 90, 180, 270. Does that make sense? Yeah. So 90 means 1 quadrant over. 180 means 2 quadrants over. 270 means 3 quadrants over, right? Okay, now you don't have to actually sit there and guess where is it going to land. There are rules. Look right here. This is where your highlighter is going to be really helpful. Don't highlight yet. It's coming in. Hold on to it, but watch this. Don't highlight yet. Remember last week when I said the written rule of every single one of these starts out the same? Remember that? And I said what comes after it is where you actually see what you're doing. Yes? Okay, so on this particular page, first I want you to take your pencil and label this as the written rules. Then I want you to take your highlighter and highlight that we're going, for this particular example, 90 degrees, and the rule is y comma negative x. Then we're going 180 degrees, and the rule is negative x comma negative y. And then 270, the rule is negative y comma x. Now let's talk about how to read the rules. Remember, the negative in front doesn't mean turn it negative. It means, do you remember? Hint, it's in one of the reflections pages. What did the negative in front of the rule mean? We drew an arrow to it and we wrote what it means on the reflect across the x or the y-axis pages in your booklet. Turn to the reflect across the x and y-axis. Negate. It means negate, which means sign change. I want you, so every single one of you, right? Tori, stay with me. Draw an arrow to this little negative right here and make a note, sign change. Now, you could make that note on all of them, but then it's going to get a little repetitive. But anytime you see a negative, it means you're changing the sign. Now, let me give you a little tip. To apply these rules, first, take care of any sign changes. Then, second, then switch if needed. All right, write that down and then I'll explain what I mean by it. So, when you're applying the rules for rotations, there's sometimes two steps involved. One step is something has a sign change, and the other step is you have to take the x and the y and you switch them, okay? Now, I say sometimes because which rule are x and y in the original positions that they started with? Which highlighted rule did x and y not switch places? Do what? The 180. Look at the 180 rule. X is still first, y is still second. Okay, so that's why I said if needed. You don't switch every time. It's just if it's a 90 or a 270, they're switching, right? If you look at them. Okay? Now let's apply the rules. So the original figure, which is called your pre-image, is already, you already have your coordinate points. Now we're going to rotate clockwise 90 degrees. Okay? Let's copy the written rule right above the 90 degrees right here. What is the written rule for rotating 90 degrees clockwise? Tell me the written rule. Like, just read it to me. It's highlighted. Thank you. It's y negative x. That's what I mean by tell me the written rule. It's y negative x. Now let's address what this means to do. This means change the sign of which one? And then take them and switch them. All right, so A is, this is easier if you say it kind of out loud or in your head. A is 1/6. Change the sign of what? Okay, so what would that be?
Negative.
-1, 6. Now what do I do with them?
Flip them.
So it'd be 6, -1. We're going to call it A prime. 6, -1. You see how I got that? All right, B is 1, 3. Change the sign of X, so that would be -1, 3. Now switch them, so it would be what? 3, -1. All right, C is 2, 6. Change the sign of X, it would be -2, 6. Switch them, so it would be 6, -2. Now graph it. All right, don't wait for me. Go ahead to the next one. Rotate 180. What's the written rule? Corey, stay with me. What's the written rule for rotating 180? -X, -Y, which means all we have to do here is on which ones?
Both of them.
Both of them.
Oh, this is-
Change the sign for both of them. We're going to actually just call this A double prime. I hate to call it A prime again because then we're going to be putting them on the same graph. This is not a domino question. We're going back to the original problems right here. Okay, so don't let the double prime confuse you. We're just trying not to confuse A prime with A prime with A prime if we end up putting all three on there. So 1, 6, what's this mean to do? Change the sign of both, so what would it be?
-1, -6.
Thank you. B is 1, 3. Apply the rule. Good. C is 2, 6.
-2, -6.
Perfect. Then graph it. Then go to the next column. Rotate 270 degrees clockwise. What's the written rule?
-Y and X.
Okay. So this means change the sign of which one?
Y.
The Y, then take them and
Flip them.
switch them. Now you are going back to your original ABC, okay? Don't ignore these columns. We're not doing a domino effect here. All right, so we'll call this a triple prime. A little excessive, but that's all right. It's just this one problem. All right, so A is 1, 6. We're going to change the sign of Y. That would be 1, -6, right? Then I need to do what with it? Switch it, so what would it be? -6, 1. B is 1, 3. Change the sign of Y. What do you get?
-3, 1.
Okay, 1, -3, and then switch them. Yeah, sorry. Then graph it. have all four on the same graph, you have this nice little, like, almost pinwheel-like image. And that's because you rotated around the origin. And you rotated correctly. If we had rotated around a single point, the pinwheel would not be centered right on the origin. It would be centered around what you were rotating around. All right, now, slide to the right in your transformations booklet, page 10. Notice it says rotating counterclockwise around the origin. So take your highlighter, let's highlight that we're going counterclockwise. Then take your highlighter, let's make a note that now 90 degrees, the rule is what you see right here, negative yx. 180 degrees, highlight the rule. 270, highlight the rule. Let's also take our pencil and make a note that these are the written rules. Let's label it. And then let's talk about real quick what direction counterclockwise is in. Remember, that's high noon. Now clockwise is the direction the clock runs. So counterclockwise would mean high noon and to the left. So let's make a note that you got 12 o'clock, but then you'd be going to the left. Once again, remember, take care of any sign changes first, then switch them if necessary. Let's write the rules. We have our pre-image, triangle ABC. We're going to rotate 90, copy the rule above it. We're going to rotate 180, and we're going to rotate 270. And then now what I want you to do is to fill it in just like we did the last one. You are coming right back to your ABC, okay? It's not a domino question. So remember, is change the sign of whatever has that negative in front of it in the formula. Then switch them if necessary. Some self-control. Don't look up here if you're not ready to check your answers. Did you get that right for the first one?
Yeah, let us see.
What? You need whiteout? Or you just want to put a sticky note over it? Okay. I do. Now when you go to draw this, especially with mine, once again the image looks a little distorted. Rotating 180, do we have to switch anything?
The sign.
We just have to flip the sign, right? Change the sign. Let's just say change, I guess, for signs, so that way we don't get it confused with switching the coordinates. So we're changing the signs, that's it. If you are looking up here and you are just copying this down, you're going to get this wrong when we take our test. And your test is Friday, by the way. Okay, so that's what we're shooting for, is to be able to test over this Friday. Make sure you are practicing with the problems in class or the digital assignment. There is a digital assignment already posted in Google Classroom. You have 4 minutes. It's up to you. I'm going to go ahead and write this third one. If you don't finish it today, you have to finish it tomorrow before you get to me, and there is no flex tomorrow. What was that? Y'all give me a second and I'll come get the highlighters from you. The digital assignment is in Google, or is in Delta Math.